Lesson 7.5 is writing and graphing exponential decay functions. Yesterday and the day before we were looking at growth functions, and now we're going to look at decaying. First, they're going to ask you to tell whether the table represents an exponential function. If so, write the rule for the exponential function. So when we look at this, for our exponential functions, the x's have to change at a constant rate, and they do. And then the y's, instead of changing at a constant rate, they have to change by the same multiplication. So I have to look at this. To go from 5 to a 1, I divide by 5, which means I'm really multiplying by a fifth. And then 1 times a fifth is 1/5, and a fifth times a fifth is 1/25. So this is an exponential decay function, and my y-intercept is 1, that's the a value, and my rate of change is a fifth, and then it's to the x. It's okay if you just write y equals a fifth to the x. It is important that you put the 1/5 in parentheses though, because then we would have to distribute the power of x. So let's try this next one. We go from -1, 0, 1, and 2, so those are all constant. I have a hard time knowing what to multiply -11 by to get a -7, but if you look at this, -11 to -7, we're adding 4. -7 to -3, we're adding 4. And again, we're adding 4. So this is no, it's not an exponential function. It's actually linear. And they're not asking you to write the rule if it's linear, so we'll just move on. Next, you're going to have to graph these. So when you graph them, go ahead and make a table. And we'll make the table just like before, so -2, -1, 0, 1, and 2. I always start with 0. And at 0, anything to the 0 power, remember, is 1. And my multiplier is 4/5. So 1 times 4/5 is 4/5. And then I'll multiply by another 4/5, and that's going to give me 16/25. Now to go the other way, I multiply by the reciprocal. So 1 times 5/4 is 5/4, and then 5/4 times another 5/4 is going to be 25/16. So when I graph this, I'm going to graph 0, 1, and then they're going by 2's here, so I'll go ahead and go by 2's. At 2, it's 16/25. It might help you if you use a calculator and turn it into a decimal, because that's about 0.6, so we'll say it's a little bit over a half. And then I'm going to look at -2, and that's 25/16, and 25 divided by 16 is about 1.6. So at -2, it's about 1.6. And then I'm just going to go ahead and curve it down. You want to make sure that it curves so that it's not going to go over the x-axis. Remember, yesterday we discussed the range is always all real numbers. I'm sorry, the domain. And my range here is positive real numbers. Or you could put y is greater than 0. Let's go ahead and look at this one. Again, I'll make my table. And -2, I'm not going to do, well, actually I will. I want to put it in order. I think it's just easier that way. So again, I'll start at 0, and when x is 0, I end up with a 1, and my multiplier is a quarter, so times 0.25, and then 0.25 times 0.25 is 0.0625. And then here, I'm actually going to multiply, I'm going to divide. When I have fractions, I multiply by the reciprocal. When I have decimals, I divide. So 1 divided by 0.25 is 4. Divided by 0.25 is 16. So again, at 0, I'll graph 1. At 2, it's 0.0625, so it's really tiny. And at -2, it's 16. Well, I don't have that on here, so I'll go -1 is 4. So that works. And then you can see it's a little bit steeper. So my domain here is again all real numbers, and my range is again positive real numbers. Now let's go ahead and look at this. When I graph it, I'll start it out the same way. -2, -1, 0, 1, and 2. Now, when I let x equal 0, I end up with an answer of 3. But my multiplier now is always just the 1/4. So this is my b value. So 3 times a fourth is 3/4 times another fourth is 3/16. Then I'm going to go 3 times 4 over 1 because I'm multiplying by the reciprocal. So 3 times 4 over 1 is 12 times another 4 is 48. And obviously I cannot fit all of these on here, but I can fit on 0, 3, and then at 1, actually 2, I can do 3/16, which is approximately 0.2. And at -2, it's 48, and I can't go up to that. And I guess my scale is not really great here. But I'll go -1 is 12, so about up enough from here. So it's going to be pretty steep. And they want us to compare this with the graph of 1/4. And all I'm going to say, it's a vertical stretch, because that's all that happened. We stretched it out because of that a value. Now let's look at this one. And again, at 0, now it's -3, because this is 1 times -3. And I'm going to multiply that by a positive fourth, so it's -3/4, and then -3/16. And I'm going to get the exact opposite here, so this is going to be a -12 and a -48 because I'm multiplying them by the reciprocal. So at 0, it's -3. And again, I apologize, my scale is really off on this. At -1, it's -3/4, so maybe right in here. At -2, it's -3/16, which is right around here. And as long as I have my 3 points, I do need to be careful though. I need to make sure, oh, I guess this is okay. Whoops. You just want to be careful when you're graphing this so that it hits your points. And as far as this is concerned, it's a vertical stretch and it's reflection over the x-axis. It's important that you say it's a reflection over the x-axis since we have 2 axes. All right, let's do this one here, number 29. Again, when I make my table, and I'll finish the table over here. But at 0, now it's going to be -1/3, and then I'm going to multiply that. Let's go ahead and do it over here when I have 1 and 2. So -1/3 times a fourth is -1/12. Now -1/12 times a fourth is -1/48. And here I'll multiply by the reciprocal, so -1/3 times 4 is -4/3. Times 4 again is -16/3. So I'll graph this at 0, it's -1/3. And at 1, it's -1/12, so it's really tiny. Well, that's 2, but it's very close to the axis. And then at -2, it's -1/48. So -1/12. Oh, I'm sorry, I was looking wrong. At -1, it's -4/3, so -1 1/3. And then at -2, it's -16/3, which is 5 1/3, so it's going to be way down here. So it'll look like this. And the comparison here is that it's actually a vertical shrink. And it is a reflection over the x-axis. All right, so here's the exponential decay model. When a quantity decays exponentially, it decreases by the same percent over equal time periods. To find this model, the only difference now is with the growth model, we had the initial value, we had the 1, but we had plus the decay rate. Now we're going to subtract the decay rate, and then it's still going to be to the power of t. So when we look at this problem, it says you purchase a cell phone for $125. So that's my A value. The value of the cell phone decreases 20% annually. That's your R value. And we make it a decimal. Write a function that models it. So we have the initial value times 1 minus 0.2, oops, 0.2 to the t. Well, I'm going to write that as y equals 125 times 80%, or 0.8 to the t, because if it decays by 20%, it's keeping the 80%. And finally, they're asking you, well, what is it going to be after 3 years? So you just plug in the 3 for the t. 125 times 0.8 to the power of 3 is 64. So after 3 years, your cell phone is going to have a value of $64. And let's look at this next one. Scientists studied the population of a species of bat in some caves in Missouri. All right, I had a phone call. So scientists studied the population of a species of bat in some caves in Missouri from 1983 to 2003. So 1983, that is year 0. In 1983, there were 141,200 bats living in the caves. That is the initial value. The number decreased annually by 11%. That is your decay rate. And first, so that's what they're asking for. The initial amount is 141,200. The decay rate is 11%, and the decay factor, so 1 minus 11%, is 89%. Now they want us to write a function. So y equals 141,200 times the decay factor, which is 0.89, to the power of t. And finally, they want to know, what is it in 2003? Well, 2003 is 20 years later. I'm going to go ahead and put it up here. If you can find room down there, go ahead. But y equals 141,200 times 0.89 to the 20th. And that is 13,700 approximately 29, bats. So we would expect it to be smaller because it's decreasing by 11% per year. All right, if you would like to start your assignment, it's going to be the worksheet, excuse me, 7.5, and I will upload it to the website if you would like it.